I guess let's start. So, hello everybody. Very happy to be here with you guys. Guess what? So, this session will be very cool and it will be way awesome and cool if you interact with us, guys. So, you have the chat, you can open your mic and ask questions, and yeah, we'll be having very good fun today. Okay? So, yeah, I guess let's start. Okay, so today we're going to talk about launching Web3 projects. And I don't mean like the theoretical stuff that you can read through internet or or through LinkedIn articles. I'm gonna share with you the actual practical stuff, like what you really need to know when you're building something from scratch. Uh, I've been doing this like for about 6 years now. I've shipped projects that worked. I've shipped projects that failed, and honestly, the failures taught me way more than the successes. Okay, so that's what I want to share with you today, and all the lessons, all the mistakes that I learned, the things I wish someone had told me when I started back then. Okay, so we've got an hour together, and I want to make it worth your time. So we're going to cover everything from picking your blockchain to writing smart contracts, to getting users as well. Okay. By the end, hopefully you should have a clear picture of what it takes to go from an idea to mainnet. Okay. Um, all right, let's go then. Let's go to the next slide. Yeah, this is a quick introduction on me. So yeah, I'm Firas Beliba. I'm tech lead at their blockchain. Yeah, these are my recent projects. Okay, Talent AI for Hacks, PowerChain, Mariposa. They are all Web3 projects, and I will explain to you like the workflow. Okay, how we got from an idea and we launched on an actual projects with actual users. Okay. Very important. So yeah, this is the today's agenda. First of all, we'll be talking about Web3 fundamentals, okay? So about maybe 10 minutes. Even if you know this stuff, it's good to make sure we're on the same page, like terminology wise, okay? After, we'll be having the architecture and tech stack, maybe another 10 minutes. This is where a lot of projects like mess up early, like wrong blockchain choices, wrong tools, like it sets you back months, and it's a very important step if it's not the most important one. Third, we'll be talking about smart contract development, about 12 minutes. It's the core of everything. We go through the full development life cycle. Sorry, I think I'm having some messages in the chat. Let me see. Cool. Let me do it like this maybe so I could see the chat. Perfect. All right. Yeah. Yes, so smart contracts development. After that, we have security. Okay, so about 8 minutes. This one is very critical. Like billions of dollars, like could get lost to hacks. Okay, so yeah, and I'm not even exaggerating. Okay, so we'll look at real examples through this presentation. Next, we have the hackathons, grants, certifications. This is a very important step as well. Okay, and we've been doing that, guys, together. Okay, so 10 minutes of that. This is how you actually break into Web3, how to win hackathons, how to get funding, and validate your skills. I'll share exactly, for example, how Talent AI went from hackathon project to
طال
getting a grant,
الانتظار.
for example. Okay, and last, like how to launch your community. Okay, great product with no community is dead, especially on Web3. Okay, so you need to focus on that as well. I'll try to keep things moving, but if something is not
الاتوار.
clear, like type it in the chat. We'll be having Q&As, like small Q&As between every like maybe 3 slides. We'll have a quick Q&A, so feel free to ask your questions in the chat and we will be answering, guys. Okay, nice. Let's get going. Okay, so next slide. I think you see it. Yeah, what is Web3? um like this it's better, I think. Yeah, like this it's better. Nice. All right. Web3. What does it actually mean? I know a lot of you already know that, but let me explain it like the easiest way. And the easiest way to understand it is to look at how we got here first. Okay, so we have Web 1, okay, or Web 1.0. This was the 90s, early 2000s, okay, which is like, yeah, internet was born. Static websites, GeoCities, if anyone remembers that. You went to a website, like you read stuff, and that's it. Like companies, they publish stuff, you consume, and that's it. We call it read only. While you're presenting, please take notes. Oh, okay, TomTom. Okay, thank you, TomTom. Okay, Web 2. So this is the transition or the evolution of Web 1. And it was very big, to be honest, okay? So this is what we've had for the last 15 to 20 years. Like Facebook, YouTube, Twitter, all the social media, all the applications. Like suddenly everyone could create content, okay, on the internet. You didn't need to know HTML. You didn't need to code. Just sign up and post. You like use an application and yeah, you are creating content. It was huge. Anyone could like broadcast to the entire world, okay? But here's the problem in this evolution. And this is important to understand, guys. When you post on Facebook, who owns that post? I know, you already know the question, the answer, sorry. Like, another example, when you build, for example, 100, like 100k followers on Instagram, who owns that relationship? Of course, the platforms, they do, okay? It's not you. Facebook can ban you tomorrow. YouTube can demonetize you with no explanation. Twitter, for example, can shadow ban you. And all that work you put in, all that, like the values you created, you don't actually own any of that. And it's very frustrating, especially for like content creators, like people who gets like their income is from YouTube, for example. They don't know if, yeah, they could get demonetized like tomorrow, okay? And it's very frustrating. You're basically renting your digital life from tech giants. They can change the terms whenever they want. And that was a big problematic, okay? Until Web3 is born. This is like what we are building now. The key difference in one word is ownership. In Web3, you own your own data through cryptographic keys. You own your digital assets as NFTs, for example, or tokens. No single company controls the platform. Transactions, they happen without middlemen. It's like the difference between renting an apartment and owning a house. In Web 2, you're just a tenant. The landlord can kick you out at any time. I know there is like law and everything, but yeah, it's like, it looks like the terms and condition that you agrees on when you create an account, right? And yeah, that's the perfect example. Like when you are using Web2, you are just a tenant and the landlord can kick you out like anytime. In Web3, you're the owner. You have the house. The keys are yours. It's very different, guys. Okay? Look at three columns in here. Like we have Web 1, which is read, Web 2 is read and write, Web 3 is read, write, and own. Okay? And that's the shift. And that's why this matters. Okay? So if you have any question about that, I assume you already know this part, guys, but just in case you know. Okay? Yeah, let's go to this part, this slide 5, which is why Web3 matters. So, is anyone actually using this stuff? Let me answer this question by numbers, okay? We have $50 billion plus locked in DeFi protocols right now. Like, that's real money sitting in smart contracts. Not banks, guys. Smart contracts. Like actual code. Like imagine money sitting in a bunch of code, guys. 500 million plus crypto wallets globally. About 6% of the world. more than the population of the US. 3 trillion peak market cap. Yeah, it's corrected since then, but that shows the scale we're like talking about. But beyond numbers, what do people actually use? Like why do they use this? First of all, we have the ownership. For the first time ever, you can truly own your digital stuff. When you have an NFT in your wallet, it's yours. It's like no company can take it. You can sell it to anyone, anywhere, without asking permissions. Second, we have, let me see if I made a slide for this. No, I'm sorry, but it's okay. Second, we have the transparency. So every transaction is on a public ledger. When a company says they donated to charity, you can verify after them. Okay? That kind of accountability doesn't exist in traditional systems. Okay? Transparency is very important, guys. We have also censorship resistance. This one's controversial but important. Like, no central authority can shut down Bitcoin, for example. For people in countries with unstable governments or currencies, this is huge. It's not about doing illegal stuff, it's about having financial sovereignty or financial freedom, okay? And that's why, for example, Bitcoin worked so well in countries like Nigeria, okay? Because simply like their financial system, it failed them, okay? And they found Bitcoin for that. We also have programmable money, okay? Programmable money. And yeah, that's the layer that Vitalik Buterin added, the programmability, okay? And this is my favorite, by the way, okay? So smart contracts let you encode financial logic that executes automatically. So think about freelancing today, okay? So you are freelancing, you do work, you send an invoice, you probably wait for 1 week or two, maybe sometimes more, maybe chase the client a little bit. It's annoying. I know it's very annoying. Yeah. But with smart contracts, client, they lock, like client will locks funds into that smart contract. Okay. You deliver the work. An Oracle, for example, could verify that. An Oracle, like, think about it like a verifiable party that will verify that you actually delivered the work or not, okay? And after that, like the funds, like they will release automatically. No invoicing, no waiting, no trust required. Of course, if you want to include invoicing, of course you could do that because blockchain and like DLTs, they are transparent, okay? So that's why this matters. Not price speculation, fundamental changes in how ownership and transactions work, okay? Because a lot of people, when I talk about blockchain, they say, oh, Bitcoin, oh, you must be rich, oh, yeah, these are stereotypes, guys. Blockchain is a technology after all, okay? It's a technology that gave us the possibility to create things like Bitcoin and Ethereum and meme coins, even meme coins, guys, okay? So we are talking about the technology in here, okay? And it's huge. It's huge. Let's go to the next slide. Let me see if there is some questions. Nice presentation. Thank you. Thank you so much. Glad you liked it. Yes, chase the clients. Yeah, I know. Yeah, I know. It can be very frustrating chasing clients when you are freelancing. I know. Blockchain is not crypto. Yes, that's right. Web3 for life. Yeah, yeah, yeah. Of course, Web3 for life. Yeah. Let's go to the next slide. Okay, guys. Let me put the chat. Okay, the chat is next to me. Do you see the slide 6? Yeah, type of Web3 project. That's very important as well. And here I just put like some honorable mention because trust me, guys, there is a lot of categories. If you open CoinMarketCap right now, you will see like, I'm not even joking, but it could be like hundreds. Okay, there's a lot of categories in like Web3 projects. Okay, but yeah, we picked few one. So let's answer the question: what are people actually building on Web3? Let me break down the main categories, okay? So we have DeFi, decentralized finance, okay? This is the biggest by money locked, guys, okay? Lending protocols like Aave, for example, or Compound, okay? You can deposit crypto and earn interest. or borrow against your holdings. No credits check, no bank approval, like just code. We trust into code and we don't trust into people, guys. Okay, we trust into code. Okay, because code is after all is binary. Okay, so either true or false. Okay, so it won't lie to you. So we trust in code. DEXs, for example, like Uniswap. When I'm talking about DEXs, yeah, DEXs is short. DEX is short for decentralized exchange. Okay, like Uniswap, for example, you could trade tokens without centralized exchange, like Binance, for example. No KYC. KYC is a protocol like Know Your Customer. Okay, it's short for Know Your Customer, and no withdrawal limits. Of course, you connect your wallet, and yeah, you could trade. You could trade whatever token you want, like, and a lot of people made a lot of money through these applications. Okay, and they earned it because trading is risky. It's another topic I won't cover it maybe today, but yeah, this is decentralized finance, guys. DeFi is complex and it's also risky, but it's where most of the innovation is happening. Okay, let's move to another category. For example, why did you say that, and what is difference? I didn't get the question, Spaceship. Could you please try to? Bitcoin is not crypto. Um, Blockchain is not crypto. Yeah, because crypto is the fruit of blockchain. Okay, blockchain is the technology. Okay, cryptocurrencies, they are a product of the blockchain. Okay, cryptocurrencies, they are just smart contracts, guys. Okay, cryptocurrencies, they are just code. That's it. Like, imagine you are creating an application with tokens on Web2, for example. You will be making a very simple database and you will be making token called X and supply, and that's it. You will distribute tokens, and every time you will reduce the total supply if you do it on Web2. Imagine the same thing but with cryptography. That's Web3, bro. Okay? So that's why blockchain is not crypto, but blockchain is the technology, and cryptocurrencies, they are just products. Okay? Like a lot of other products, by the way. And we will talk about them. Okay? So yeah. Let's move to another category, which is the NFTs. It started with digital art. I think you know Bored Apes, like the monkey NFTs. CryptoPunks as well. I think you saw like Neymar and Eminem and a lot of famous people, artists. They bought these pictures or crypto collectible, I would say. But it's way more than art right now. Okay, so it was like, yeah, back then was a trend. But trust me, guys, NFTs. Yeah, for example, Bored Ape NFT is not Bored Ape, but Bored Ape is an NFT. Do you see the thing? Bored Ape is a fruit of NFTs. It's a product of NFTs, but we could use NFTs for a lot of other use cases. Okay? Gaming items, for example, that you could actually own. Like, imagine like skins, weapons in games, etc. Like, they could be NFTs. Music sold directly to fans, even though I don't like the music use case, but yeah, it's feasible. Real estate tokenization, that's the thing. That's the thing nowadays. So you could lend, like you could sell your land or your house, and you could tokenize your house into an NFT, and you just like sell the NFT. The NFT, it's like the paper that proves that this house is yours, and you transfer this ownership to another person. Okay, your diploma, for example, you had a certificate, guys. I think when you get the email, yeah, it will say to you like it will say to you, you could mint this certificate as an NFT. Okay, because you could tokenize it into the Hedera hash graph. Okay, so yeah, this is another category, by the way. There is another one, very famous one, which is DAOs, okay, or DAOs. Yeah, we call them DAOs. They are, yeah, it's short for decentralized autonomous organization, and they are governed by token holders, okay, like a company where every stakeholder, like votes on everything. Like treasury managed by smart contracts, no CEO making like decisions on these kinds of things. Everybody votes, okay? So that's a DAO, a decentralized autonomous organization, and the decision taken is by everyone actually. Okay, famous example we have MakerDAO, who manages billions through community governance. Experimental, often chaotic, but pioneering new ways to organize. Of course, we have some questions in here. Absolutely, because blockchain is just a form. Exactly, exactly. While crypto is only, yeah, definitely, definitely, Emmanuel. I would like to know only one thing. What are you discussing now? Could you please let me know? Yeah, yeah, we are explaining how to launch your Web3, okay, Web3 project, how you can launch your Web3 project from scratch, how you could actually do that. This is like an introduction for the next steps, okay? So yeah, um, yeah. Let's go to the next category. We have also gaming. It's very famous right now. So play to earn like models, they are very famous. Axie Infinity at its peak. Like people in Philippines, they are earning more like playing the game than at minimum wage jobs. Like there's a lot of people who quitted their jobs because they get actual money from these games, and sometimes it's more than their salaries. Okay, so you actually own your in-game items as NFT and you could trade it. Okay, as well we have other categories like infrastructure. This is like the peaks and like the picks and shovels, okay, of Minecraft. You know, like oracles, for example, like Chainlink. It's very big, like bringing real world data on chain, because you know, like blockchain and off chain, they are like two separate words, okay? And Chainlink stands in the middle in order to bring the information off chain to bring them on chain in order to trigger events, okay? We could maybe create like future sessions if you want. I could explain oracles for you in details, but it's not the focus of today. We have also categories like identity, okay? Like there is a lot of use cases of identity, like self-sovereign identity, ENS domains, okay? Instead of like your wallet address is very long, right? 0x12, I don't know. Yeah, you could change that by just simply like firas.eth or daniel.eth, okay? It's like the DNS of domain name system of websites, okay? Instead of an IP address, you could put, yeah, firas.com, or I don't know. Okay, so these are use cases of identity and many, many, many others. Okay, cool. What do we have? Money through playing. Okay, that it really depends. It really depends, Daddy. It really depends on their business model. Okay, but there is a lot of like games with the play to earn model. Okay, you could, yeah, you could check that yourself on the internet. It's very famous these days. Okay, maybe one day I could do another session, maybe explaining to you how play to earn works. But trust me, we have a very long, yeah, long presentation that we need to cover. So yeah, if we had like maybe 10 minutes at the end for your Q&A, I will try to answer all your questions. Okay. So yeah, let's move to the architecture right now, and this is very important. Okay, this is very important as well. Let's get a bit technical now. How does Web3 app actually works? Okay, a lot of you wonder like, how do we develop a decentralized application? Is it like regular Web 2 or maybe different? Actually, it's very, very similar, guys. Like, don't get confused. It's very, very, very similar. Okay. We have three layers. We have the front end, okay, which is the front end of the application or the decentralized application. Like, this looks almost like regular web development. You could use React, Next.js, Vue.js, yeah, JavaScript, TypeScript, whatever you want. The difference is what your front end talks to, okay? And yeah, hold on in here. Like the front end usually talks with a database. Okay, yeah, not the front, but instead of your backend and database, you are talking to blockchain nodes and user wallets. Okay, of course you could do some hybrid architecture that you use database and blockchain at the same time, and trust me, this is one of the healthiest one. Okay, but instead of talking only to database, okay, or instead of only talking to your backend and your backend will talk to the database, your backend will talk to blockchain nodes and yeah, user wallets. The front end will talk with user wallets. Okay, so this is what changed. Instead of login with password, you have connect wallet, for example. The user connects MetaMask or hashpack or whatever, and the wallet becomes their identity. Key tools at this layer like Ether.js for Ethereum stuff, Hedera SDK for Hedera, WAGMI for React hooks, for example, RainbowKit for wallet connection UI, etc., etc., etc. And there is a lot more. Okay, and usually every blockchain like they have their own own SDKs and things. Okay, what do we have more? We have middleware. Okay, so this is where beginners mess up. They skip it and wonder why their application is slow and expensive. Problem 1. Querying blockchain is hard and expensive. Try finding all NFTs owned by this address with rare trade transferred in the last 30 days. Like even saying it in a phrase, it's very long. Imagine a query, okay? That query is brutal on chain, okay? So solution for that, we use indexers like the graph. They watch the blockchain, they organize data into queryable databases, etc. Problem 2, for example, smart contracts, they can't access external data, okay? They don't know the Ethereum price, for example. And it could be very confusing. I know Ethereum is, yeah, it's on blockchain, etc., but they don't actually know the price of Ethereum. It's an off-chain data. They don't know who won the football match, for example, who won between Barcelona and Real Madrid, okay? The solution in this step, we have oracles like Chainlink, for example. There are networks that fetch real-world data and publish it on chain. And they belong to the middleware layer, okay? Problem 3, for example, we have on-chain storage. It's crazy expensive. Storing an image, for example, like, yeah, better forget it, guys, okay? It's very expensive. For that, we have decentralized storages, okay? We have IPFS, we have Filecoin, we have yeah, we could store files there. Like, put just the hash on chain. You only put the hash of that image on chain, like the mirror of it, okay? And last, we have the blockchain layer, okay? This is where smart contracts live. Your application logic and state, like consensus mechanism, validates everything once deployed. Yeah, it's permanent. Like, here's the flow. User connects wallet, they trigger action, front end creates transaction, wallet signs it, transaction hits the blockchain, smart contracts executes. After that, we go to the middleware part, indexers picks up events, and front-end updates. Can I repeat it maybe so you could understand it better maybe? This is the flow, guys. Imagine I connect into my wallet, okay? When I connect into my wallet, I trigger an action, okay? When I trigger an action, the front end creates a transaction. When I create a transaction, I need to sign it with my wallet, of course. With what I could sign it with my wallet, okay? And after signing it, the transaction is sent to the blockchain. But where exactly? Into the smart contract, sorry. And after that, the smart contract will execute. You could put in the transaction, for example, yeah, I want to execute this function A in that smart contract, okay? And after the smart contract executes, for example, calling any function of your choice, we go to the middleware layer. And there we have the indexers who picks up the events and fire events, okay? The smart contract will fire event and the indexers will pick it up, okay? And when the front end notice that an event has been picked up by the indexer, it updates the state. So you can see, for example, yeah, my balance updated or something like that. Okay? Do you get it, guys? It sounds complex, but once you get it, everything else like makes sense. Okay? So yup, let's go to the next slide. Choosing your blockchain. This is a very, very, very important step. Like, one of your biggest early decisions is which blockchain will I pick. This matters. Switching later, trust me, it's very painful, and I've been there, and it is not a very good idea. Let me break down the options. So I'll start, like, this is few blockchains, guys, but trust me, there is like hundreds, not maybe thousands of blockchains out there. Okay, so you need to wisely pick your blockchain. For example, Hedera. Yeah, I start here because it's what I use most. So yeah, we have, for example, criterias or KPIs. Okay, so we have, for example, 10k TPS, not theoretical, but yeah, but actual performance. Visa does about maybe 1,700, something like that for comparison. So it's much scalable. The cost is very, very cheap, like $0.0001 per transaction, basically free. This matters more than you think. If users pay $5 gas for a $10 purchase, they won't use your app, trust me. If they want, like, I don't know, a smartphone case or something like that with $10 and they pay $5 additional on fees, yeah, they will never use your application again. So Hedera in this case fits more. So Hedera, for example, it uses hashgraph consensus, different from typical proof of stake, like mathematically proven, like mathematically proven security. Okay, it's proven that it's secure. We also have governance council, includes like Google, IBM, Boeing, etc., etc. It might be having some downsides. Maybe smaller ecosystem than Ethereum. I don't know, fewer tools, fewer protocol to integrate with, but it could be beneficial for other perspectives. Means means opportunities. Since the ecosystem is not as big as Ethereum, I could build more solutions. I have less, maybe people or less actors in the market with me. Okay, so it really depends on your project. It really depends on your perspective. Ethereum, for example, the OG smart contracts platform, like still king of DeFi and NFTs. Speed, I'm talking about 10 to 30 TPS on mainnet. Mainnet, sorry. It's way slower than Hashgraph. Hashgraph, we said like 10,000 TPS. Like Ethereum is 15 to 30 TPS on mainnet. Like there is more on layer 2s, but on Ethereum, yeah, it's very slow. The cost, it varies widely. Sometimes, yeah, when it is called, it could be like $3, sometimes $50, sometimes $100, sometimes even $250, sometimes more. It really depends on the congestion. Okay, if there is a lot of people trying to use the network, trying to execute transactions, they will try to put more gas fees, and yeah, like that you will even pay more in order to prioritize your transaction. On Hedera, we don't have transaction prioritization, so that's why the gas is fixed price to the dollar. Okay, so, and by the way, this is the biggest Ethereum problem. Okay, but on the other hand, we have ecosystem largest by far, like like most developers, most tools, most liquidity, in terms of security, like most battle tested, like running since 2015 with trillions secured, so we good. Okay, best for DeFi NFTs, maximum like composability with existing protocols. If you don't know what to use, Ethereum or an Ethereum layer 2 is the safe choice, of course. But yeah, but in here it really depends on your use case. If you want something maybe popular, if you want something, if you have like a team with like proficiency in Solidity, you won't choose Solana, for example, because Solana uses Rust. Okay, you will choose Ethereum. But also, on the other hand, could you handle like transactions with congestion? Does that matter to you? Do you have like a big volume or a big traffic transactions or something like that? So you need to consider all these details when you are trying to choose a blockchain. Let's compare Solana, for example. It's the speed king, okay? Like speed up to, yeah, it's a lot of transaction, okay? It's a lot of transactions. I think it's even more than Hedera a bit, okay? But it's very theoretical, guys. It's very theoretical. We never tested that, okay? We never reached like it's very theoretical. I think 40,000, yeah. 40k, I think. But it's very theoretical. We never reached that, okay? On the other hand, Hedera is tested, so it's good, okay? So cost, it's very cheap, not as cheap as Hedera, but it's cheap. The catch in here, it uses Rust, not Solidity. And when we say Rust, it's steeper learning curve if you are coming from web dev or if you have a team with like Ethereum developers. And Rust developers, they cost more usually, okay? Rust developers, they have very high salaries, okay? So for that, you need to consider your option as well, okay? But it's best for high-speed apps, games, consumer products, okay? Yeah, there is a lot of rumors that like Solana, it's not very secure. It's maybe sometimes a bit centralized, but yeah, it could be your option. It really depends on your use case. Okay, Polygon, it's layer 2. We talked about already Ethereum, so yeah. So how to choose in here? If you need low costs and speeds, for example, you could choose Hedera. If you need maximum ecosystem, Ethereum or Polygon. If you know Rust and need speed, you could choose Solana, okay? This is like between three blockchains, but there is more, guys, okay? I won't cover them in this presentation, but don't overthink it. You can bridge between these chains anyways. You can deploy on multiple chains. Just pick one and start learning, okay? And yeah, when you land on an idea and start to launch your project, maybe we will get back to this conversation, okay? So do we have questions? If there is question, guys, please don't hesitate. I think we good. I think we good. Okay. Uh, Slide 9. So, yeah, these are essential development tools. So, what tools do you actually need in order to be like these stuff? Okay. So, smart contracts development, especially. Okay. So, Solidity. Why I said Solidity? Okay. This is the main programming language in smart contracts. About 90% of smart contracts use it. Okay, there is other programming language, of course, like Rust on Solana. There is Go. The yeah, like Cosmos, for example. There is yeah, I forgot the name. Move, yeah, Move. Of Aptos and Sui. Okay, there is a lot of programming languages, guys. There is even blockchains who creates their own programming language, guys. Okay, like Aleo blockchain, they have yeah Leo. They call the programming language Leo. So there is a lot of things, but Solidity is the OG. Okay, it's the most used one. So if you know JavaScript, it'll feel somewhat familiar, okay? So curly braces, semicolons, functions, like they exist in JavaScript, they exist on Solidity, so you will feel a bit familiar, okay? What we have else? Hard Hat. Most popular dev framework gives you local blockchain for testing, and it's very important when you are learning, okay? Deployment scripts, debugging tools, you can even console log in Solidity, which is wild, by the way, okay? Which is something like crazy console logging in Solidity, okay? So, great documentation as well. you could use it if you are new here. Okay, so what else? We have Foundry. It's newer, it's faster, it's written in Rust, and Rust is a low programming language, so it's very efficient in these kinds of products. Okay, so it lets you write tasks in Solidity instead of JavaScript. Yeah, I use this now for most projects, but Hard Hat is better for beginners. Okay, what do we have else? Open Zeppelin. This is not optional, okay? But they provide audited, battle tested implementations of common stuff. Like they are crazy smart engineers who've built like design patterns and smart contracts already audited that you could use them and import them directly into smart contract, okay? Like stuff like ERC20 tokens, ERC721 NFTs, access control patterns, security breaches, design patterns, a lot of stuff that you could use. If you already tested like developed a smart contract on Ethereum or on Hedera, I think you already used or you already know the Open Zeppelin name. Okay, you could check them; they are very good. Uh, the most important thing, guys, we don't reinvent the wheel, guys. It's very important. If something already developed and made and tested, there is no need to redevelop it. If you want to do it just for the sake of learning, it's cool. But if you are creating a project, don't reinvent the wheel. These guys, they are very good. They are very smart. They already did their thing and it's tested, it's audited already. Like thousands of smart contracts uses them. So, okay, we use them. That's the standard. These contracts secure billions of dollars, by the way. Would you I hate reinventing wheels. It's pointless. Yeah, yeah, exactly. Yeah, I hate it too. I hate it too. Trust me. Would you mind, please, to send us the record of session, the record of session? Yeah, when you finish the presentation. Thank you so much. At least the presentation. Yeah, definitely. I will send you the presentation, guys. I don't know if somebody is recording right now, but I will check with the team. Okay. Yeah. Thank you so much. Yeah. Yeah, let's talk about remakes, guys. Okay, I know, guys, you are probably AI guru. You use AI everywhere. Okay, like Cursor and Cloud Code, and I don't know. Yeah, but remakes is for people who wants to learn and maybe not cheat with AI. Because trust me, guys, if you don't know how to use AI, you will. Yeah, you won't yeah, it will be a bit tricky. Okay, so try to use Remix if you are a beginner. It's an IDE, browser IDE that you can open on your browser. You don't need to install anything, no setup. It's just good for learning and quick experiments. I still use it sometimes for testing ideas. So yeah, Remix is a good go to. Okay, on the front end, what do we have? Ethers.js. It's the main library for interacting with Ethereum compatible chains. Okay, even Hedera, because guess what? Hedera is EVM compatible. So we could use ethers.js in order to interact with Ethereum compatible chains. From JavaScript, yeah, it's like clean API, good docs. It's really cool. It's really cool. You could use it. There is a lot of others libraries very similar to this, but Ethers is the most important popular one. Sorry. What do we have else? Hedera SDK. If you're on Hedera, available for JS, Java, Go, a lot of programming languages, guys. Like Hedera, guys, they are so crazy. They created like hundreds, not hundreds, but a lot of libraries with multiple programming. No, literally like hundreds of libraries. They have a lot of libraries. They have a lot of libraries. They have an open source community, very strong one. So there is a lot of stuff that you can find there. WAGMI as well, which is React hooks for Web3 stuff. And this could be your best friend when you are developing, when you are a front end developer, of course, and you are developing an application on Web3, decentralized one. So, yeah, so it makes wallet connections, contract interactions much cleaner and very, very easy. Okay. Rainbow Kit, there is also. It's a pre-built wallet connection UI, okay? I think a lot of people used it in the last hackathon, okay? Just drop it in and instant professional look. There is the UI, there is everything. You could connect with your QR code. yeah, everything is there. Last thing to mention, Alchemy or Infura, if you are developing. They are node providers because guess what? DLTs, they are decentralized. So there is a lot of nodes. And in order to communicate with your smart contract, you need to connect to a node first, okay? And these guys, they are node providers. They give you nodes to connect to. You don't want to run your own node, of course, unless you want to maybe try to do a simulation on your local host, okay, local machine. Um, and these give you API endpoint to hit the blockchain. Okay, free tier, like the free tier is very generous. Okay, enough for dev to work. Okay, not for production, but for dev, it's like very generous. Critical thing at the bottom. Okay, so we have always used testnet first, guys. Okay, Hedera testnet, for example, Ethereum, Sepolia. I forgot about the Polygon one. I think it's not Mumbai anymore. Yeah. It's been a while since I developed on Polygon. But yeah, use testnet, guys, okay? Deploy there, test everything, break it, fix it, then only then you touch the main net, okay? You do all your experimental stuff on testnet, okay? I've seen people lose thousands of dollars just deploying buggy smart contracts to mainnet without testing. Don't be that person, guys, okay? So yeah, we have a question, I think. Do we need to be dev earlier before succeeding at smart contract? No, to be honest, no. We all started at some point with just basic Web2 development, okay? If you know the basics like OOP and all of these stuff, you can start your career at smart contract development. But what you need to do is, yeah, try to do some smart contracts. Try to work personal projects. Try to do these kinds of stuff. Try to learn courses, okay? Take courses, okay? Because there's a lot of standards. There's a lot of best practices that you need to learn in smart contracts because they are a bit different than traditional Web2 development, okay? But in terms of programming language, yeah, it's not. It's very familiar. You won't feel like it's not homesickening. Trust me. Okay, so you can start. I encourage you. Uh, I guess let's go to the part four. I think it's part four or part three. I forgot. But these are the smart contracts fundamentals. Yeah, and thank you, by the way, Mamadou, for this question because that's why they are not familiar. That's why Web 2 and Web 3 they are a bit different from each other, especially in coding. Like I'm talking about like design patterns and best practices, etc. Because actually smart contracts fundamentals they are very different. Okay, so smart contract the core of everything in Web 3. Like simple definition, they are self-executing code on blockchain that automatically enforces agreements when conditions they are met. It looks complex, but trust me, yeah, I will try to repeat it again. They are self-executing code on blockchain. Blockchain, the technology, guys, okay? That automatically enforces agreements when conditions are met. Or we could simply say that triggers actions when conditions are met. We say agreement because yeah, it's a smart contract, the word for the contract word, okay? But yeah, think of a vending machine, for example. I really like this example. You put in money, select an item, machine gives you product, no human involved, rules they are just mechanical, okay? You don't need to talk with a person, just insert the coin, get the product, and yeah, that's it. That's a smart contract, guys. That's literally a smart contract. Okay, smart contract is like a digital vending machine for any kind of transaction you want. Okay, for example, do you want to sell your NFT? Contract says like when someone sends the price transfer NFT to them and send payment to you, automatic. Want lending, for example? Contract says deposit collateral, borrow up to 50% of value. If collateral drops too low, liquidate. Automatic. Do you want voting example, for example, guys? Contract says each token holder vote once, like automatically, and when you vote, like the decision, like the proposal is voted on, and yeah, it's closed, automatic. Okay, this is a smart contract, guys. It only trigger actions only if the conditions written into it are met. Okay, so one of the criteria of a smart contract, it is immutable. Okay, once deployed, code cannot change ever. Okay, but there is some use cases like Aptos, I think. Aptos is a blockchain where you could do upgrades on your smart contract. So technically it's not very immutable. Okay, there is a small backdoor that you could use it to update your smart contract. That's why we talked about you need to choose wisely your blockchain, guys. It could, like, Aptos could be the best pick for you if you want to upgrade your smart contracts every week or something like that. Aptos could be your go-go. Okay, so yeah, you need to do your research. So yeah, smart contracts, they are immutable. This is good and bad, as I told you. Good for users, they trust it won't changes. Okay, it won't change. Sorry. So the users will know that the smart contract will be always the same way. Okay, and they could read the code. Of course, it's transparent. Okay, um, and the bad, if you have a bug, you can't fix it. That's the annoying part, guys. If you deploy your smart contract with a bug, yeah, you probably need to close that smart contract and upload a new one. I know it's bad, but that's why there is testnet, guys. That's why you need to test your smart contract. And you need to make sure that there is no bugs before deploying into mainnet. Okay? It is also deterministic. Means same input always gives same output. Always. Okay? Why? Because thousands of nodes run your code. Okay? If they got different results, blockchain would never agree on a state. So no randomness unless specifically programmed. Okay? So no external API calls, everything deterministic. It is trustless as well, so you don't trust the other parties, you trust the code. It's cool, right? So if I write a contract that pays you when you deliver, you don't need to trust me personally. You read the code, it's just there, it's deployed, it will never change. You see payment is logged, yeah, you good. You know execution is automatic. Okay, so for the first time ever, trustless agreements between strangers, like, it happened. Okay. So yeah, another criteria is transparent. So anyone could read the code, anyone can verify the state, anyone can see every transaction, and anyone could see the code. So if there is bugs, he could exploit them, and he could hack you. So that's good and bad. So you need to make sure that your smart contract does not contain bugs. Okay, very important. Let's go to the next slide, which is the development cycle. This is also very important. Yeah, I think all the slides, they are important, guys. Yeah, so 6 phases, each one matters. Keep any at your own risk, trust me. Okay, so phase 1, we have the design. Okay, before writing code, you need clarity. What problems are you solving? What functions does the contract need? What data gets stored? What events get emitted? Write it down, not in your head, on paper or docs, because we are human beings and we forget, guys. We forget, sorry. Okay? So draw diagrams, write specs, think about edge cases. What if someone sends zero? What if they withdraw more than they have? What if price drops to zero? Like, these questions, they are good, trust me, okay? So think about access control. Who calls which functions? Are there admin functions? Who's the admin? Like, these questions, they are very good. I spend at least 30% of project time in design, guys. It feels slow, but it prevents massive problems later. Phase two, it's the development. Now you write code, some principles, write tests alongside code, not after. Okay, it's very important. And yeah, this I have this example, guys. It's very funny. Okay, but when I prepare food, okay, and I have dishes right now, and I need to clean the dishes, okay, it would be better if I leave my food to rest because it's very hot and I go clean the dishes and after that I eat food. But imagine if I eat this day, okay, I leave the dishes, tomorrow I will do the same thing. After 1 week, I have like a mountain of dishes, okay? Same thing, guys. Okay? It's the same thing. You write your tests alongside the code. Whenever you write a smart contract, you go write the test script. Okay? Unit testing, you go do them. Okay? It's very important. So, not after, okay? Just alongside the code. Like write functions, write tests, like keep it simple. Every line is a potential vulnerability. Of course, you need to think it that way. Okay, every line in your smart contract, it could have a potential vulnerability. So the more lines you have, the more potential vulnerability you will have, the more probability that you will get hacked in the future. These things, they are stressful, so you need to think about them. um so yeah, the developing part is very important. Document everything. Solidity has NatSpec, I think, for documentation. Use it, and yeah, future you will appreciate it. Okay, so yes, phase three, it's the testing. So after you develop your smart contract and everything, you need to test the smart contract is different. And since you have written your unit tests, so yeah, you're good. You will just run the tests and try to make some scenarios. Okay, just try to execute a lot of scenarios. If everything works, you're good. You're not just checking if it works, so you are checking if it works in every scenario, including like the classic one. Okay, units test each function individually, like each function individually. You need to test it, of course, and like how contracts interact, edge cases, failure cases. Like think like a hacker. Okay, just think like a hacker and try to hack your own code. Okay, even try to ask some friends, like, please try to do me an audit. Okay, please try to read my code if I have something wrong. Okay, because yeah, I know when you audit yourself, yeah, you won't find any bug, trust me. You'll say to yourself, oh my god, I did such a good work. Yeah, I'm a genius. Okay, so you won't find any errors in your code. So try to ask other people to do that for you. Okay. Phase four, it's very important, and I already talked about it. The audit, not optional if you are handling user funds, but internal audit first. Team reviews each other's code, run static analysis. We have Slither, Mithril, external audits. Like these tools, like they help you. Okay, you could try to hire a professional if you got access on some fund. Okay, so if you have money, you could hire a professional to do the audit for you. There's a lot of companies who do really good audits. Open Zeppelin, even they do audits. Okay, and phase five, which is the yeah, it's a very important phase, because now you tested the smart contract. Now you will deploy it to testnet first. Okay, do everything exactly like mainnet. Verify contracts on Explorer, double check parameters, owner address, it is correct, it's not correct, like you check that. Initial supply, is it correct? Yeah, and you're good. Phase 6, which is the last one, is deployment isn't the end, by the way. It's a start of an operation, okay? You need to monitor the events, set up alerts for unusual activities, maybe have emergency procedures ready, etc., etc. So you need to monitor, you need to watch. Uh, yep, I think that's it for this slide. Testing strategy, I'll try to be quick on this one. Yeah, this is how you test your smart contract. So you have, yeah, let me go deeper on testing because this is where people like cut corners usually. I see projects with 30% test coverage thinking they are ready and they are not. Okay. Think of it, it's like a pyramid. Okay. Unit tests, they aim for 90%. Testing individual functions uh, in isolation. Okay. For every function, ask, does it work with normal inputs? Does it handle edge cases? Does it revert when it should? Does it emit correct events, etc., etc.? Like simple deposit function might need 5 tests, like normal amount, zero amount, max amount, when paused, correct event emissions, etc. We have also integration tests. They aim for 70% plus. How do contracts interact together? Your DAX probably has router and pool contracts. Integration tests verify they work together correctly. So this is mainly for connections between smart contracts. You have also end-to-end tests. They aim for 50%. This is the full user journey, like how the user connects, how the user deposits, how he waits, earns, withdraw, receives rewards, etc., etc. Like this is the UX of your application. Okay, run on testnet with real network condition, of course. We have the fuzzing test. I think you already know um, this word, fuzzing. So it is automated random test, like tools like yeah, I forgot the name. Sorry. Yeah, I think it's, yeah, Echidna. Yeah, exactly, Echidna. Yeah, yeah, I wrote it down on the presentation. Sorry for that. Echidna. Yeah. So these tools, like they generate random inputs, trying to break your smart contract. So they are trying to stress your smart contracts and finds bugs human never think of. Okay, so fuzzing tests, they are very important. What other tools we have? Like hard hat, most popular for JS and TS tests, Foundry, Solidity test, much faster, Slither, static analyzer, Mithril, symbolic execution, Echidna, which is a fuzzer. So yeah, it's like, so after you pass all these tests, like, yeah, you probably, then you are ready. Okay. So yeah. Do you have any question, guys? By the way, are you good? I think. Yeah. I think it's longer than I thought. Okay. 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 Cool. Perfect. In terms of regulation of the standards, yeah, we'll cover this in just a minute. Okay. Until now, everything is good. Would you love the way the second automatic scan? Yeah. At least already learned myself. Nice. Does it require money to do all these procedures? Yeah, it really depends, buddy. So, yeah, these steps, yeah, you could do them for free, of course. Okay, all these tools, they are open source, and you could install them on your computer unless you want to do an external audit by some sort of famous company. Okay, because we have this thing in Web3, we have reputation things. Okay, we go to big companies with good reputation on audits. Okay, because they audited other smart contracts and they work today, so we go to them because they have good reputation. Okay, but yeah, this is like the last step if you want to do an audit with an external person. It's like marketing. Okay, it's like marketing because you put it on your website. Hey, we are audited by Open Zeppelin, come check us. Okay, but if you don't do an audit, it's usually a red flag because people won't trust you because simply they don't know you. Okay, they don't know you, so they will be skeptical about using your application. It could have a bug, it could get potentially hacked in the future. So that's why we go to like famous like organization that do these audits because they have a reputation for that. Okay. Yup. So, uh, security and auditing. Yeah, we will talk about this. So this is the most important part of the whole presentation. If you remember one thing, like from today, remember this section: 3.8 billion. Like, guys, please focus on this. This is scary. Okay, 3.8 billion lost to DeFi hacks in only 2022. Billion with a B, okay? Let me tell you about some of these. Ronin Bridge, $625 million lost by hacks. Ronin is a blockchain for Axie Infinity, by the way. Bridge connected like to Ethereum. Used multi-sig wallets, 9 validators, need 5 signatures to approve. What happens? The attacker got access to 5 of the 9 private keys. Like how? Yeah, social engineering, poor key management, I guess. And with 5 keys, he drained $6.25 million. 600, sorry, $25 million. Okay. Team didn't notice for almost a week. Like imagine, guys, the team they didn't notice that for almost a week. Yeah, yeah, we have the Nuri. He's the attacker, bro. That's cool. That's cool. So the lesson: security isn't just code. It's operational security after all. So you have like how you store your keys, who has access, etc., etc. Do you want more? Wormhole, guys. Wormhole. $320 million lost on hacks. Bridge connecting multiple blockchains. The vulnerability is that one function that verified signatures didn't validate properly. The attacker could say, "Trust me, I'm a guardian," without being one, and forged signatures and withdrew $320 million, guys. One function, one validation error. $320 million, they are gone. Do you want else? Nomad, $190 million. This is the one, like the most embarrassing one. They pushed an upgrade that accidentally made contract accept any message as valid. Like, do you imagine that? Yeah, yeah. The devs must be like burned out, man. Like they did an upgrade and that accidentally made contract accept any message as valid, like no conditions. One person figured it out and took some funds. Others saw it, copy paste same transaction, changing just the recipient address. Hundreds of people, many with no hacking experience, just copy pasting to steal $190 million in hours. So the security mindset in here. So assume your code has bugs. Just assume it, okay? Say my code probably has bugs, okay? Defense in depth. So try to do multiple layers. Um, Fail safely, okay, on testnet, okay, it limit damages. Keep it simple. Your smart contract is good, not because it contains thousands of lines of code. That's a bad smart contract. Keep it simple. Less code means less bugs. And document everything. Document everything, guys. Okay? Do you want to hear about some common... Yeah, I'm sorry. This is... Wait, what? Yeah, common vulnerability attacks. So these are like vulnerability attacks that could happen and how to fix them. We have reentrancy, the classic, the Dow hack in 2016, $60 million lost. Your contract calls external contract and external contract calls back before state updates, like prevention checks, effects, interaction pattern, and Open Zeppelin created for that something called the reentrancy guard. And this is why we don't reinvent the wheel, guys. We use the re-entrancy guard of Open Zeppelin. We just import it from their library and we use it in our code. And like that, we avoid re-entrancy attacks. Integer overflow. Old solidity match could wrap. Okay, so like like prevention, like the prevention for that solidity 0.8 plus, I think, has built in like checks for that, I think. So I think we are good for this error. It's not common anymore. So we are good. What do we have else? Access control, like missing permissions checks. Anyone calls admin functions, for example. The prevention for that, just use Open Zeppelin ownable or access control. Okay, these are design patterns and functions that you could use ready to go. Just plug and play on your smart contracts. Flash loan attacks, like borrow enormous amounts, manipulate prices, drain protocols. The prevention for that, just time weighted average price, which is TWAP or TWAP. Okay? Front running, very famous. Attackers see your transaction in a mempool, executes first, and yeah, they put more gas fees so they get prioritized. And yeah, for that, you comment reveal schemes, private mempools, okay, in order to prevent that. Oracle manipulation, we have also. External data can be manipulated. Prevention for that. Decentralized Oracle like Chainlink. Okay? Each of these has caused like 9-figure losses. Not even joking. They are all preventable with proper patterns. Okay? Let's go the audit process. Yeah, this is for the most curious one. Okay? This is how the audit process. How do you actually get code audited? So step 1, prepare. Code freeze, documentation, comprehensive tasks, clean code. Step 2, internal review. Before going to an organization that do audits and pay thousands of dollars, try please to audit your smart contract first. Don't embarrass yourself, okay? So step 2, internal review, team code review, static analysis with Slither, Mithril, aim for 100% test coverage. After that, we have step 3, external audit. You could hire professional auditors to do architecture review, manual code review, automated analysis, edge case testing. Yeah, it usually takes from 2 weeks to 4 weeks, I think. Step 4, fix issues. Okay, critical and high severity must be fixed. Medium should be addressed, but critical and high, it must be fixed. Step 5, re-audit. Verify like fixes they are correct. Sometimes fixes introduce new bugs. Okay, and this is how you enter the loophole. Okay, so try to verify that the fixes they are correct. And top firms, of course. So Trail of Bits, Open Zeppelin, Consensus Diligence, Certic, Hacken. These are very famous. Yeah, yeah. Contract audits. Yeah, they varies from for $5,000 to yeah to even sometimes $100,000, like 100K. It's very expensive, I know, but there is companies who do that for $2,000, maybe less. But you are buying the reputation in here. You will go to Consensus because it's famous and they have made a lot of audits. Okay, you could go to X or Y. They are not famous, but it's marketing when you say, "Hey guys, I am audited by Consensus. Use me." Okay, use my application. Okay, so yeah. I'll be honest, I got an idea of buy me $100 course, you will find everything there. To be honest, I got an idea from all of this. Come and register a company with me. Okay, yeah, you are. Yeah, have fun, guys. Okay. Yeah, you're having fun in the chat. That's cool. That's cool. Let's go to slider 16. Yeah, this is hackathons and launchpad. This is very important. So let's say you already have your MVP. By the way, if you prepared your MVP, you don't need to do the audits in that step. Okay, sorry. So but what you need to do is maybe participate in hackathons, maybe participate in grants, certifications, these kinds of stuff. So it's very important. Why you should participate in hackathons? First, You learn by building real projects. Like reading tutorial is one thing, but actually building something under time pressure, that's where real learning happens. You will learn more in one weekend hackathon than in a month of tutorials, okay? Trust me. Second, prizes. We are talking about very huge prizes, guys. You saw like the last hackathon, like $2 million, like of prize pool, like a lot of money. Okay, so the winning project, they have like a very generous pool of prizes. It really depends on the hackathon, of course, but the main one, the very big one, like usually like the prize pool is at least 200K. Okay, like that's real money for a weekend of work, guys. Sometimes a weekend of work. Okay, so even if you don't win like the grand prize, there are usually sponsor prizes, bounties that are easier to get. So yeah. Third, visibility. Like VCs and protocol teams, like they watch hackathons. So they are looking for talent and ideas. Like you could maybe meet someone who could help you on your project, maybe give you a funding, etc., etc. Fourth, your portfolio building, guys. Like every hackathon project is something you can show, like to future employers or investors. Okay, it's real code with real demo. Okay. Fifth, networking. You meet other builders, mentors, judges. These connections, they are invaluable in Web3. Okay, and let me give you some tips how to actually win hackathons. Uh, you need to solve, first of all, a real problem. Don't build something cool but useless. Judges love practical utility. Ask yourself, would anyone actually use this? Okay? Working demo beats slides as well. In the last hackathon, I've seen a lot of cool presentations and cool demonstrations, video demonstrations. But the actual website is not working. There is like mock data. It's such a red flag, okay? Don't do that. So you need to have a working demo. I can't stress this enough. A rough prototype that actually works beats a beautiful presentation with no code. Like try to ship something, okay? Use sponsored technologies. Sometimes it's a hack when there's a hackathon with sponsored technologies. Like for example, this hackathon is sponsored by Bolt or sponsored by Chainlink. Try to use Chainlink, okay? Like sponsored prizes, they are often easier to win than grand prizes. So yeah, write a great README as well. README is on GitHub, guys. Try to write a good one. Judges like they have limited time. If they can't understand what you built in 2 minutes, you've already lost. Like clear problem statement, how it works, how it won, etc. Of course, a demo video. Many judges won't clone your repo. Like they probably watch the demo, the video demo, and after that they will go to the code. So try to give good impression in the video. Okay. Try to like a 2 minute or 3 minute video or even a 5 minute video showing your app working is gold. Okay. And of course, where to find hackathon? Yeah, there is plenty of platforms of that. Dura Hacks, ETH Global is the biggest. What else? DevPost. Soon their blockchain will be having one. We'll share it with you guys. Okay. So yeah. Slide 17. Where is it? Grants. Yeah, so this is how you get money. I think this is the most important one for everybody. Okay. But you know, when somebody will gives you money, yeah, he will probably be waiting for something in return, okay? He won't be giving you money for free. So grants are my favorite funding source. Why? Because they are non, let's say you get the money, you don't give up equity or tokens. It's literally free money to build, okay? There is major grant program like the Hedera Foundation, the Ethereum Foundation, Gitcoin grants, Solana Foundation, Polygon grants. There's a lot of foundation for that. And how to actually win grants? I've gotten grants and I've reviewed grant application, and here's how it works, guys. Trust me, it's very important. You need to have in a document a clear problem statement. What problem are you solving? What does it matter? Don't be vague, okay? Working prototype, having even, let's say, a basic MVP, but yeah, but try to do something cool at least. Um, but it shows you can execute. That's very important. Realistic milestones. Try to do a roadmap. Break your project into phases. Show you like you've thought about what you will deliver and when. And don't promise the moon in 3 months. Also, okay, it's very important. Technical credibility. Show your GitHub, your past projects, your LinkedIn, your team's experience. Prove that you can build what you are proposing. Okay. And of course, community engagement. If you already have users or community, that's huge. That's a very big plus. Because blockchain, they always look for, yeah, they are blockchains, they are layer one, they need volume, they need transactions on their chain. So if you have users, they will execute transaction by using your application. So it's a big plus. Okay. And of course, open source. Most grant program prefer open source projects. Okay. It really depends, but yeah, because it benefits the ecosystem. Okay. Um, what else? This is for you guys, which is Web3 certifications. Okay, they are very important for you, first of all. And also, we are building a new certification platform, guys. It will be ready soon. We will communicate about it in the right date. Okay. But for now, what I advise you, yeah, try to get certified. Okay. Stand out in job applications. Like when a company get 200 applications for Web3 developer role, certifications help you stand out. They show you're serious. You've invested time and learning and probably money. Okay. So it's very important. Structured learning, like certification, force you to learn comprehensively. You might skip topics when self-learning, but certifications programs cover everything. Verify your knowledge. LinkedIn credibility, like added certifications to your profile gets attention from recruiters. Okay. Also on-chain credentials, like some certifications now issue NFT, like Hedera. Your certification live, like it is live on blockchain, verifiable, portable, yours forever. Okay, this is the future of credentials, by the way. Top certification to consider maybe Alchemy University, Consensus Academy, Blockchain Council, Hedera certification, of course, Chainlink Bootcamp. There is a lot of platforms like who like have these kinds of certification. Try to pick like credible one. Okay, try to pick credible one. Not like Udemy, for example. Udemy, okay, they are good for self-learning, but not for credibility, guys. Try to take one from universities, from big foundations like Hedera, Consensus, etc. Okay. Uh, Tokenomics. Okay, this is one of the last topics, I think. Tokenomics is very important. Do we have a question? Coursera is good, of course, buddy. Coursera is very good because they have certifications from universities, okay, and that gives a lot of credibility. Like you could take a certification from INSEAD or Buffalo University or whatever, okay. So Coursera is good. It's a bit expensive, but it's good. But there's financial aids for students. So yeah. Uh, Tokenomics. Okay, this is a very tricky topic. I'll try to maybe not dive into details, but if your project has token, you need to understand tokenomics. Please, one thing you need to know. You have a Web3 project or you are building a Web3 project. It's not mandatory that you create a token, guys. Okay? Not because you have a Web3 project, you need to create a token. We just explained that tokens, they are products of blockchains. Just like your application is a product of a blockchain. Okay? So, having or building a Web3 project doesn't mean you need to own a token or not own a token, create a token or develop a token. But if it's the case, you need to understand tokenomics. Tokenomics is the economy of tokens. First question, does your project need a token? That's the first. Most important question, Most project get strong. Token is not way to raise money. It was back then when it was like the wave of ICOs and things, but not now, guys. That's securities offering. Legally complicated, don't do that. Tokens should have a utility, a reason to exist. For example, a token for governance. Holders vote on decisions by sending tokens. So if I have one token, I could vote on a proposal in my governance. That's why I buy these tokens. After that, the price speculation, all of that, something else. Okay? Access, for example. I need tokens to use a specific service. Okay? Staking. I need to lock tokens to secure network earn rewards. Payments, if it's a cryptocurrency within the ecosystem, like Bitcoin, for example. Okay? Um, it could be Ethereum, it could be Solana, of course. I should not mention Bitcoin, it's a very different use case. But yeah, you get the point. So if you can't like articulate clear utility, don't add token. Tokenless projects, they are perfect valid, okay? They are perfect valid. So key questions you have here. Token supply? Is it fixed like Bitcoin? Is it inflationary? Is it deflationary with burns? You need to specify this. The distribution, guys. Like typical one, for example, from the supply, I will allocate 40% for the community, 15% for the team, 20% for the investors, 15% for the treasury, 10% for the ecosystem. Like these allocations or distributions, okay? Vesting, that's another question. Should the team vest like 3 to 4 years with 1 year cliff? Investors maybe 1 to 2 years? What does vest means, guys? It means when I send you the tokens, you cannot sell them. You need to wait for a period, okay? I give you, for example, 200 tokens, but you cannot use them. They are just there. After 2 years, you could use them. Okay? So this is called vesting. And it's good because it's healthy for the project. Okay, I can give 15% for my team and I will give them 4 years vesting. So I could make sure they won't sell my token, because when they sell my token, the value will decrease and this will be unhealthy for my project and I don't want that. Okay? What creates demand also? Utility, staking rewards, government's right. Speculation alone isn't sustainable. So get tokenomics wrong and your project will fail automatically. Get it right and you've built a sustainable economic engine. Okay? I won't dive deeper into the tokenomics. Let's go to the funding options. So what do we have for funding? Who gives us money? Okay? So we have I'm sorry, is it the funding or I skipped one? Yeah, the funding options. We have the grants, we have the VC angels, we have the launchpad, we have the bootstrap, okay, which is the self-funded development, and I don't advise that, okay. We have launchpad, VC angels, and grants, okay, and I already explained how you could contact them, okay, in the previous sections. Now let's talk about building community. Building community is very important as well. Very simple. Yeah, Web3 people, they are crazy, okay? They are crazy. Community isn't just marketing, it's everything. Great product with no community dies. Mediocre product with passionate community can succeed and improve. Discord, your home base. Most engaged members lives there. Like structure it well, announcement, read only, general chat, support, development, all of that kind of stuff. Twitter or X, like it's your megaphone, okay? How you reach beyond existing community, what works, daily presence, threat. Daily presence, like daily post means, hey, I'm here. I'm not dead. Your money is safe with me, okay? That's what it means when you post, like when you publish a post, okay? Telegram as well. It's a good tool in Web3. So some prefer it for simplicity, good for quick updates and regional groups. GitHub, of course, for technical projects, crucial. It's public repos, build trust, contribution guidelines, responsive to issue and PRs. So yeah, and this is how you build a community, guys. You need to take care of these platforms. Uh, yeah, this is a launch strategy that I built. Okay, that could be interesting for you. So we have pre-launch 2 to 3 months before, like building community, start Discord, Twitter months before. Like early supporters become most loyal advocates. Okay, and you could even make airdrops in the future and reward these early adopters and early supporters because they pushed with you in the beginning. Create documentations, user guidelines, dev docs, FAQ, like get ready before the launch. Testnet release, of course, if you are if you are making a decentralized application, just launch it on testnet and announce that product in front of users before mainnet. Let them find bugs, iterate, bug bounty if you want. Pay white hats, okay, which is good hackers to find vulnerabilities. Uh, um, yeah, there is platforms like Immunify, for example. It's a standard platform like for these white hats things. The security of blockchain only relative to no, but the big chunk is in the smart contract. Okay, the very big chunk is it's in the smart contract. So you need to pay attention on that. But the really big chunk, it really depends on the use case. But the really big chunk, it's I would say 90% in the smart contract. Okay. Thank you, Amado, for the question. Um, Thank you, Shara. Thank you. Glad you like the tips. Yeah. Next phase, which is launch week, so mainnet deployment. Carefully, like try to verify on Explorer initial liquidity. If you have token, ensure there is liquidity. PR push, press releases. And here's where Twitter comes. Influencer outreach, announcement everywhere, like ads, etc. Community AMA. AMA, they are very important because like team is meeting the community and they are talking about how they actually made this happening. Okay, direct Q&A with the team, like the office hours that we do with our blockchain. Uh, this is how you build trust. Also, partnership announcement, guys. I forgot about it. Partnership announcements, like it's also very important. And of course, the next phase is the post launch, like monitor and iterate, like watch everything, analytics on chain data, community feedback, fix fast. Okay, this is like the legendary difficulty. Okay, if you have a bug, you need to try to fix it as fast as possible. Okay, that's why you need to make sure there is no bugs, so you don't put yourself in these kinds of situations. Okay, future updates. V1 isn't final, of course, so ship improvement constantly. Publish your roadmap. Community governance. If you want to create a DAO for the community, if they want to change some things or add some features in your application, if you have token, progressively decentralize it. Best protocols constantly they improve. Okay, so launch is milestone one. Sorry, not the finish line. Okay. Uh, yeah, the SR Immunify. Yeah, I know. They are so good, and you could do them, and you could get bounties. By the way, you could get money if you found some bugs. So it's that's really cool. Thank you, Digital Kerofi. Thank you so much. Um, it's so amazing. Hope we'll go on until 2 or 3 hours again. Thank you, guys. Thank you so much. I'm very glad you liked this session. Thank you so much. Create. Let's go to the This is creating your roadmap, okay? And for people who want the hackathon, they sent their roadmap recently, and they had some problems how to write the roadmap and these kinds of things. I know it sounds a bit frustrating, but trust me, guys. Try not to promise the moon. Try not to put unrealistic numbers. You are building a, I don't know, like a social media application. Don't say I need $500,000. Like, come on. Like, nobody will believe you. Okay. So try to put realistic numbers. Okay. So every project needs a roadmap. Most roadmaps, they are terrible. And here's how to do it right. Do this. So, as I said, realistic and achievable. Try to under promise. Okay? And after that, over deliver. Okay? Milestone based, not date based. Don't say by the end of February I will be finishing this milestone. No, just say Q1, Q2, Q3, Q4. Okay? Just try to to put these words. Um what else? Milestones you control. Like dates you often don't. So it's very important to put these. Don't do this as well. Over promising timelines, like vague target like Q3 2024 with no specifics. Like try to set and forget, like stale roadmap equal inactive project. Okay? Simple milestones like this. For example, don't name your milestone Q3 of 2024, name it MVP launch. 1000 users, audit complete, token launch, 10,000 users. The like these titles, okay? So each milestone unlocks next phase, like it gives you meaningful progress, okay? It's like you're playing a game, okay? You have achievements, okay? Like I don't know, I play PS5, PlayStation, so I have like platinum trophies, okay? So I get trophies when I play game. For example, when I don't know, when I do something in the game, they give me a trophy. Yeah, you did this, okay? Same thing in here. You need to put it on your roadmap. So it really looks like the platinum trophy list of PlayStation, guys. Okay, so yeah, we have some questions. So thank you so much. Please, can we have access to the? Yes, definitely, definitely. You know what? Let me give it to you right now. Just yup, copy link. Yeah, I think you should get it right now. I think you can open it. I don't know. Yeah, that's the link, guys. I think it works. Yup. Yeah, I think. Yeah, maybe that's the link. I don't know. Yeah, this one. Yeah, this one. This one should. Yeah, sorry guys about that. I think this one will work. Yeah, thank you. Nice, nice. That's cool. Nice, that's cool. What else? Pre-launch checklist. Yes. So before mainnet, these are the checklists. So smart contracts, they need to be audited. The testnet needs to be verified. The documentation needs to be complete. You have a website, a landing page, and a decentralized application live. Wallet integration tested. The gas optimization, they are done. The emergency pause function, and there is a whole design pattern for that. Like this is a safety mechanism. Like imagine I launched my smart contract and I noticed there is a hack. Okay, we use Possible. We use Possible from Open Zeppelin. It's an emergency button. It's like a red button. When I click on it, all the smart contracts shuts down. Like it shuts down. Like stop. No more function works. Okay? Because I discovered that somebody like trying to exploit some bug in a function. So I stopped the smart contract to minimize risks, to minimize losses, sorry. Okay? How can we get? Yeah, I already sent the link, Azra. I think. Do you get it? Yeah, it's just scroll above. It's. I already sent it. Sent it. So yeah. Also, community channel active. Yeah. The pre-launch, you need to have at least some Telegram groups, some Twitter pages with at least like few thousands of followers, guys. Okay, come on, like you could do that. Tokenomics, they need to be finalized if there is a token. legal compliance reviewed. Okay, just prepare your lawyers and everything. Okay, you never know. Just try to contact them, some legal advisors. The team, it needs to be verified on LinkedIn and everything. The bug bounty should be live. The monitoring setup and the support team is ready for questions. So if you have all these, this is a healthy project. This is a healthy pre-launch. Okay. Of course, this is perfect. Like, this is the perfect use case. Of course, you could maybe try to miss some things, but this is the perfect one. Okay. These are the common mistake. What to avoid? Skipping audit. If you are, yeah, if you want to make an application, and trust me, I've seen a lot of decentralized application who didn't do audits. Yeah, because they claim their code is good, etc., etc., and after that, yeah, they are just legacies on the blockchain now. Nobody used them. They are hacked. Yeah, they are just there. Yeah, for a reminder. Okay, just a reminder for other people to do audits before go on mainnet. Okay, so yeah, it's very important, the audit. Ignoring gas costs. Okay, users won't use expensive contracts. So if you have heavy contracts, no, like with no gas optimization, and imagine every transaction I will do on your smart contract, I will be paying like $20 in gas fees. I won't be using your application anymore. So the gas optimization is very important. If you don't have no upgrade path, it's a red flag as well. Means you can't fix bug after deploy. Okay, so you need to have an upgrade path. The copy tokenomics, every project is different. Like, don't copy tokenomics. Okay, never do that. Okay, over promising timeline. Like, don't over promise, guys. Like, don't raise the bar, because after that people will be disappointed and you will be losing. Okay, so don't do that. Poor key management. Try to manage very, very well your keys, because if you lose them, yeah, you are in a very big problem. Okay? When it's a SPOF, it's a single point of failure that you need to avoid. Fake community. If you are trying to buy Twitter followers, it's okay if you do it maybe the first time just to give good impression. But after that, yeah, you need to stop buying fake communities. You need to make ads. You need to make like real followers, because bots don't convert to users. Okay, you could have like millions of bots and nobody uses your application. Okay, and of course, you don't need to ignore regulation. You need to verify the regulation first, because you could be flagged. Okay, and could lead to legal issues that can kill the projects entirely. Okay, so yeah, these are the resources. Okay, in order to learn, I put them in the presentation. You could check them, guys. The Hedera Discord, the Ethereum Discord, Solidity by example. These are like some few names that I like. Like, yeah, you could check them. And the key takeaways: security first. Always audit before mainnet. Start with hackathons. Okay, build, learn, try to win grants. Okay, that's where you start. Get certified. Validate your skills. Test extensively. Test nets are your friend in this case. Build community authenticity, quality over quantity, and apply for grants. Of course, grants that, yeah, because they are free money actually. So yeah, I think I finished the presentation, guys. Do you have any questions? Maybe let me try to read the question. What tool you recommend for fresh startup to use to protect private keys? There is hundreds, not hundreds, but there is a lot of ways to to protect your private keys. There are cold wallets that you could use. You could use multi-signature wallets as well. Uh, but yeah, it's very controversial. But I would go for cold wallets. But yeah, when there is a case that you need to store your private key elsewhere in order to execute a transaction, that workflow I don't like, because it's not self custody anymore, and it will even put more pressure on me, because if I lose these keys, then my clients will do too. Okay, so I'll try to give the self custody to the users in order to execute transactions by themselves and protect the keys by themselves. If I am just like protecting my treasury, like my smart contract treasury, for example, I would use cold wallets. Okay, because cold wallets, they are, yeah, they are hardware wallets. They are not connected to the internet, and nobody could access them unless they break into your house, something like that. And even if they do, they cannot access them since they don't know how, like the pin. Okay, because there is a pin. Unless you forgot the pin, and that's a big problem. So yeah. What do you recommend for fresh? Yeah, I already answered that. How can we get these slides? Okay, you can use the follow through that link. That's the link. Yeah, thank you so much. Thank you so much for request to speak. Is there any host with us present right now? Maybe TomTom or
Yes. So I'm
yeah, there
gonna
is
put
somebody who wants
Amar
to
on the
speak.
floor. Yes, it's
Yeah,
Amar.
please
Okay,
go
here
ahead.
we go.
Please, meanwhile, let me bring some water, guys.
Okay.
Need
Um, so I
Hey, buddy, what's up?
kind of kind of sick a little
Yeah.
bit. Yeah,
Yeah,
that's why my
I hope
voice
it's a
is
quick
so bad.
recovery for you.
Yeah, thank you. So before I go to my questions, I just want to remind everyone that uh, Web3 is not like technology in the term, but it's multiple protocols. Okay, I've done a deep research on it since 2021 because of my end of training internship. So I did a lot of research, and Web3 was basically not just an upgrade, but the whole reinvention of Web2. Okay, that's the first thing maybe everyone needs to know. And
Yeah,
it is
yeah,
purely network thing. It's not about any database thing. It's purely network thing. Okay, it is the how to implement the peer-to-peer protocol.
exactly,
You
buddy.
can,
Exactly. I agree with you. Please continue. Yeah.
yes, that's the first thing. Okay, this has not Web three has nothing to do with blockchain in the first place. Okay, it's not related directly. Blockchain, on the other hand, is directly related to Web three. It's like A implies B. It's not the other thing around. Okay. So it's like from Web3, we developed the blockchain system. Okay.
Yes. Yes.
That's the second main thing maybe everyone will confuse about. Okay, and you can check that from the 1980 to the 2000. Okay, when the first paper of Web3 protocol has been published. Okay. After that, blockchain did not have smart contract in the first place. The smart contract system was implemented inside Ethereum, I think, but not in the Bitcoin. So it's like the smart contract was basically how to implement consensus algorithm without like re-implementing it every time. Okay,
Yes.
that's
Yes.
the third main thing that I find most of the people has confusion about.
Well,
The
thank
fourth,
you. Thank you.
the
I
fourth,
think you've made your research about that, so I can. Yeah, congratulations for that. Thank you.
yeah,
Yeah,
it's
I think.
still
Please
time. It's
continue.
like
Yeah.
5 years from now that I didn't do any blockchain system, but
Yeah.
after doing the Hedera training and get the certification, I just have refresh system on my head because
Nice. Nice.
uh, yeah,
Well, there is multiple certification coming in the future, so get ready for that.
yeah,
Just guys, try to invest in yourselves. Trust me, guys. When you invest in yourself, like it's the best thing that you could do in these times, these crazy times with AI waves and all of these stuff.
Yeah,
If you use
really
AI like
forget about Web
yeah, not
two.
in
Yeah,
the proper way, you will harm yourself. So try to invest in yourself, guys. It's the best time to do so. Please.
to be honest, forget about Web two. Go to Web three.
Yeah, it's okay.
Literally that.
Yeah, it's okay.
Okay.
Thank you.
Um,
Thank you so much. Thank you so much.
the fourth thing that the most people don't understand, that blockchain was primarily implementation of Web3 in a way that had three major systems. Okay, the first one is how to make many nodes connect to each other without anything, and the reason for that is the RPC protocol. So basically, each node connect to another node with the RPC system. Okay,
yes.
that's for sure.
Yes.
And when you execute a function inside the system, there is a consensus protocol that are going to like do everything to verify what type of operation is it. If it's a get system, or just uh, a new way of changing the state. And the most important thing is this: to understand the blockchain, you have to understand this. Each operation that changes state is a transaction.
Yes. That's true. That's true.
That's the
Transaction is not about sending money, or transaction is just you are triggering, like trying to trigger a function in some random smart contract you have on
yeah,
blockchain.
exactly.
Yeah. So when
And
I say transaction, you send a transaction means you are sending a request to trigger some function
yeah,
in your
exactly.
smart contract. Could be
Yeah,
read or write
and
or whatever.
yeah, and most of the transactions on the network are payable. That's when the
That's
fun
about
comes.
the right one. The read one, they are free. On Hedera, you have the read one. They are like very. They are not expensive at all. They are nearly free, but you could use mirror node for that. But
Yeah,
on
yeah,
Ethereum, for example, they are free.
Yep.
Only the right like the right functions, you pay transaction fees for that, and
yeah, yeah,
it's like it,
yeah, and
yeah, you
that's
are
not
paying for
okay.
the computational power. That's it.
Yeah, 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 exactly. So when transaction came, the consensus will work. That's the third part important about blockchain.
Yes.
The fourth part is many consensus algorithm need mining.
It really depends. Yeah,
Yeah,
that's
it
why. By the way, I
depends.
told you guys it it really depends on the consensus.
Yeah, yeah,
Um,
but I
yeah,
mean most of the algorithm from 2018 to the 2021, most of them are using the mining. Okay, and the reason why, because the governments try to fight this new system. Okay, because
yes,
Yes.
it gave many people a lot of money and escape totally the system.
yeah,
Okay, and that's
Yes.
not good
Sorry,
for the
Omar. Omar.
governments. That's the truth.
yeah,
That's the
Could you hear me, Omar?
hard cold truth about it. But
yeah,
Could you
yeah,
hear me,
yeah,
Omar?
people
definitely.
who didn't find it, they just joined them.
Yeah,
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 exactly. That's the
sure.
idea. Yeah,
Yeah,
and
but that's for all the blockchains. Yeah, there is some new ones who use mining, but
yeah,
my
and
why we
that's
use mining because it's the most secure. Okay, yeah, it's the
yeah,
most
yeah,
secure
exactly.
because it requires from you to solve a cryptographic puzzle by spending computational power from your computer or your server or whatever. Okay,
Yeah,
and by that
that's
you give a proof
and
of
from
work
this
that
that
you work.
comes my third question. From this part, uh, I have like uh, I had an idea at that time is to make the mining parallel system. Okay, I don't know if it's possible or not, but this is my main idea. The main
What's your main
idea,
idea? Could you say it again? Could you say it again, please?
the mining is based on algorithm, okay, mathematical algorithm. Okay, and the
Yeah.
mathematical algorithm said that you have to get a lot of transactions and
Hmm.
then just create the nonce part that it is the optimal part, but in the same time get all the informations about the other transactions. Okay, that's the main problem, mathematical problem. Okay, and there are a lot of implementations that I found, but the
Hmm.
real problem is each platform has its own native mining system.
Of course.
Okay, so my idea was on Ethereum. So if I could just take the mining part and instead of having all these for each systems, because there are a lot of for each and a lot of files, if I could make it a parallel system, okay, and each card has its own uh, uh, like system of instruction, it's going to be on the graphical cards related to it, and then gets the response, then the equation will be optimized eight times. So I gain
Omar.
more money with that. What?
Yeah, Omar, could you please, if you, yeah, this is your idea. You said, could you please maybe send me some technical paper or something like that so I can read separately? But yeah, I have a lot of questions. I won't ask them now because I think yeah, this session should be 1 hour. By the way, we went like 2 hours, and people that are trapped in here. So let's try maybe to
Yeah,
get some other questions. But please send me your technical paper about your idea, and I will give you like
yeah.
a very constructive feedback about it. Maybe I have some ideas. Okay.
Okay. Uh,
But thank you, Omar. Thank you so much for your
just my
comment.
second. Okay, just master the question. When we use Web3 as an internal service, and we use Web 2 as an external service, that does mean we lose the major.
No, 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 no. Like the modern Web3 architecture is a hybrid one. Okay, you use database and you use blockchain at the same time. Why? Because blockchain is very expensive, and storing data into blockchain is very, very expensive and could make your transactions very expensive on gas fees, and that will make your users, yeah, they will flee. Okay, so what you need to do is try to use database for information that your smart contracts doesn't need. Okay, your smart contract doesn't need all the data of your application, but it handles maybe one module or two modules. Okay, so for example, if you have, yeah, a certification module, something like that, don't store the name, the title, the description of the
Yeah.
certification into the blockchain. Like store it in a database because it's cheaper, first of all, and you won't make your smart contract heavy. Okay, because your smart contract won't need the name and the description. He only needs maybe to mint a certificate. Okay, so try to make a hybrid architecture, okay? So that won't impact your architecture. Trust me, okay? Try to use hybrid architecture, guys.
Okay, because
Like,
I did that. I did that on 2021. That same system, okay, with Ethereum and MySQL. And what I found that each request has 20 seconds for each request, which is bad for me, but I don't know if
yeah,
I
it really
have.
depends. That's the choice of your blockchain. You could have went, for example, on Hedera. It's faster, or Solana. It's faster. That's the choice of the blockchain, and that's why you need to choose wisely your blockchain. It really depends on your use case. Why we don't see some games on, yeah, we see games on Ethereum, of course, but why all the games they go on in, yeah, on layer 2s and on Solana? Because the gas fees they are cheaper and the transactions they are faster. Like imagine you are buying an item and you are waiting for, I don't know, maybe 2 minutes or 3 minutes, you will freak out and you will say, yeah, something is like something went wrong. You will try to close the game and you will do a lot of unnecessary stuff. If you use Solana, it's instant and you pay much, 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 much less gas fees. Okay, that's why we choose Solana, Hedera also for gaming. Even though there is not a lot of use cases on Hedera, but Solana, we see a lot of use cases of gaming in there. Layer 2s of Ethereum as well. I'm talking about layer 2s, guys, huh? Not Ethereum itself. Okay? So, yeah.
Okay,
I hope
so
I answered your question.
Yes.
okay, so
Thank you, Omar. Please, if anyone
okay.
else have a question, just raise your hand.
Thank you, Omar. Thank you so much.
Thank
You're
you.
Glad
welcome. Yeah,
glad that you like the session and you are here with us. Thank you.
thank you.
Yes.
Thank you so much.
If anyone else have a question, just raise your hand, Shabib.
If you don't have any question, guys, that, yeah, it's okay. It's
Yes, we
okay,
already
guys.
reached 2
It's not
hours.
necessary. Yeah, I think they don't have a question.
Yes, yes, yes. Okay, so let's close the space. Thank you, Firas. Thank you guys for coming. We're gonna share the record on our YouTube channel. And yes, see you
Yeah.
on the next session, inshallah. Okay?
Okay, thank you so much. It's my pleasure to be here with you guys and love you all. Thank you so much, guys. Thank you so much.
Thank you, Firas. Yes.